Objectives 6 and 7 are adding and subtracting fractions. When I'm adding and subtracting fractions, I need to make sure that I have a common denominator. So the first thing to do is to try to find that common denominator. For these two fractions right here, the denominators are 6 and 8. So when I'm finding the common denominator, I'm going to look for the first common multiple. So for example, 6, the multiples of 6 are 6, 12, 18, 24, and 36. Those are the first couple multiples. And for 8, the multiples are 8, 16, 24, 32, and I've already gotten a repeat. My repeat right here is 24. So 24 is going to be the least common denominator. When you're thinking about the list of multiples of 6 and 8, or whatever your denominators are, it's the first multiple that's on both lists. It needs to be a multiple of both of the denominators to be the least common multiple or least common denominator. So my LCD in this case is going to be 24. So my next job is to rewrite these fractions and then figure out what I need to multiply each fraction by to get that 24 to appear in the denominator. So when I wrote it out, I left some space right here so I can figure out it's 6 times 1, 2, 3, 4 to get me 24. So I'm going to multiply both top and bottom of this fraction by the same number, and then multiply this one by 3 because 8 times 3 is going to get me to 24. Okay. So when I rewrite, this fraction becomes 20. 5 times 4 is 20, over 6 times 4 is 24, plus 3 times 3 is 9, over 8 times 3 is 24. So they've got common denominators now. 20 24ths plus 9 24ths is 29 24ths. So I need to get a common denominator so that I'm able to add them up, then add the numerators and keep that common denominator. 20 24ths plus 9 24ths is 29 24ths. Okay, let's look at the next one. 15 and 10 are my common denominators. The multiples of 15 are 15, 30, 45, etc. Multiples of 10, 10, 20, 30, 40, etc. And my repeat is going to be that 30. It's going to be on both lists. Okay. So for some of the smaller ones, like maybe 6 and 8, or even 10 and 15, you might know that it's 30 without making the list. The list is a way of showing that you have the least common denominator and also reinforcing what that means to be the least common denominator or least common multiple. So it's useful to do it in practice, but if you are comfortable with those numbers and don't want to write the list, I'm not going to say that it's something that you must do, but I do think it's useful. So I'm going to rewrite these again, 7/15 and 3/10. Now these steps right here, you would definitely want to show on paper. You're going to multiply this one by 2, multiply the top by 2 as well, and 10 times 3, so multiply that one by 3 to get to 30. So this would be 14 over 30 minus 9 over 30 equals 14 minus 9 is 5 over 30. Now I can't circle that one and call it done because 5 over 30 is not reduced, so I better go ahead and reduce that, but divide them both by 5. It's going to give me 1/6. That's going to be my final answer. I didn't really talk about reducing on the last one because 29 24ths was already reduced. There's no number that goes into 29 and 24. In fact, 29 is prime, so I knew that one was reduced already. But I do need to make sure I'm checking for that constantly. Is my fraction reduced when it's in my final answer? Okay, let's go ahead and look at the next couple. Okay, 12 and 18. Let's see if we can find that common denominator. So 12, 24, 36, 48, and let's go down to 18. 18, the next one I think is 36, and that's going to be our repeat. Alright, so we're going to multiply the first fraction by 3 on top and bottom. Oops. And the second fraction by 2. on top and bottom. So 5 times 3 is 15 over 36. Plus the next one, 5 times 2 is 10 over 36. So this one's going to end up with 25 over 36. Okay, the only thing that goes into 25 is 5 and 5 does not go into 36, so this is reduced. Okay, now to do my subtraction with mixed numbers right here, I can do that subtraction with the whole numbers separately from the fractions, as long as I make sure I have a common denominator in the fractions. So usually I'm going to write these vertically, so I can write it as 3 3/4 minus 2 1/3. Just like if you're subtracting two-digit numbers, you're going to subtract from this column and subtract from this column, making sure I get common denominators. Okay, so the common denominator here, if I make my list of 3, 6, 9, 12, probably already knew it was going to be 12, and 4, 8, 12. 12 is the first number to appear on both lists, so it's going to be my common denominator. So 4 needs to be multiplied by 3, top and bottom, and this fraction here with 3 needs to be multiplied by 4, top and bottom, to get a 12 in this denominator. So I'm going to change this to 3 9/12 minus 2 4/12. So 9/12 minus 4/12 is 5/12. And 3 minus 2 is 1. So my answer is 1 5/12. Now it's also okay to have done this with improper fractions, and if you wanted to convert this to an improper fraction, 1 times 12 is 12 plus 5 is 17/12 is also an acceptable answer. If you would have converted them to improper first and then subtracted them, that's also fine. Okay. Unlike multiplication and division, you can subtract or add mixed numbers as well as improper fractions. If it's multiplication or division, I would have had to have changed them to improper first. Let's look at the next page. Objective 8, solve problems involving fractions in algebra. So I'm going to determine whether 27/35 is a solution to this equation or not. So again, I'm going to plug this in for n. Notice that there are two different n's right here. So I'm going to plug this in for both of those n's, and then I'm going to just see if the result is equal to 3/7 or not. So we start with 2/9 times n, so times 27/35 plus 1/3 times 27/35. Let's just figure out what that's equal to, and we'll see if it is equal to 3/7 or not. So I can do a little bit of reducing here, this multiplication. 9 goes into 9 once, 9 goes into 27 3 times. So that's going to leave us with 2 times 3 is 6 on the top, and 1 times 35 is 35 in the bottom. A little bit reducing over here as well. 3 goes into 3 once, and 3 goes into 27 9 times. So that's going to leave us with 9/35. If I add those up, that'll be 15. 9 plus 6 is 15/35. Okay, doesn't look like it's equal to 3/7 yet, but if I reduce, these can both, oops, I meant to write 35. I was thinking that I could divide them by 5 and then get 7. Alright, so I'm going to divide them both by 5, because that could be reduced. So when I divide by 5, I do get 3/7. So the answer to this one is, I'm trying to determine whether or not it is a solution. So the answer is yes, it's a solution. Okay. Alright, example 9. Translate from English to algebraic expression. First of all, I want to determine if it's an expression or an equation. Oops. So a number decreased by 1/4 of itself. Number decreased by 1/4 of itself. I don't hear any verbs or any is or yields word, so this one is not going to be an equation. It sounds like it's an expression, so it's not going to have an equal sign. No is word, it's just a fragment right here. So a number, that's my variable, is decreased by, okay, we're going to take something away from it, 1/4 of itself. So that's 1/4 of, remember, was a multiplication word with fractions, itself. So that's how it's going to look. It's going to look like x minus 1/4 x. I don't need to write the dot in between to stand for the multiplication. It's implied. Okay. And I think this is our last example for the section here. The temperature of a cool fall day is 68 degrees Fahrenheit. So we're going to use the formula C equals 5/9 F minus 32 to find the equivalent temperature in Celsius. Okay, so we're going to plug that 68 in for F. So C equals 5/9. The temperature in Fahrenheit was 68 degrees minus 32. I'll figure out what this is in Celsius. So 5/9 times 68 minus 32 is 36. I can imagine that being 36 over 1. 9 goes into 9 once. 9 goes into 36 4 times. So when I simplify, that'll be 4 times 5 is 20 over 1. I don't need to write the over 1, because 20 over 1 is better written as just 20. It's more reduced. So the answer is 20 degrees Celsius. So 68 degrees is about 20 degrees in Celsius, or is 20 degrees in Celsius. That's the end of the section.